For folks that don't actually know about nanotechnology, this is the science of manipulating materials at some really, really incredibly tiny size, almost down to the atomic level. And what are called nanomaterials are things that are made of materials that have been put together at this really, really tiny size. And what turns out, when things get that small, they have all sorts of unusual behaviors that the same materials won't at a larger, more conventional or even micro size. And this opens up a whole world of possibilities for material scientists. They can make some really amazing targeted drug pharmaceuticals that will go to a very specific organ and attack a particular kind of diseased cell. They've been able to make bandages that will kind of knit together on their own, so you don't need adhesives and things like that. And so there are all sorts of really wonderful uses for nanomaterials. On the other hand, because their behaviors are so unusual and we really don't know how they behave yet, particularly in an uncontrolled environmental setting or even in the human body, an awful lot of people, myself included, have some questions about exactly when it's a really good idea to be using nanomaterials.
And right very often they're not labeled on the product.
Exactly. That's what I was just going to say. Right now there are hundreds of products that have nanomaterials in them, and in this country it's not required to label them. There's no system for verifying that if a manufacturer says something has nanomaterials in it, it does, or vice versa. Europe, I think beginning this year or next year, will require labeling of nanomaterials in cosmetics, but we don't have anything like that, so it's really hard to know. And the only kind of comprehensive source of this information that I know about is a really fascinating database that something called the Wilson Center, a project on emerging nanotechnologies is put together, and it's alphabetical, or you can sort it by kinds of products, and you'll find nano in everything from socks and fleece hats and mittens and underwear to golf clubs and face creams. And personally, I find this a little bit disconcerting that we've got materials that we don't know what they do that are all over the place.
Right, and then when you say like a nanotech enhanced drug can target a particular organ or go to the brain, well, maybe your face cream is doing the same thing. We just are not aware of it.
Yeah, we really don't know yet, and actually quite a lot of work is being done at a number of universities, both in the U.S. and all around the world, to try and, as quickly as possible, come up to speed and share toxicology and ecological information about nanomaterials, just because it is such a challenge to deal with them and test them. So it's going to be really tricky to get comprehensive information on these.
If you're just joining us, I'm Beth Greer, and I'm speaking with Lizzie Grossman, author of Chasing Molecules, about synthetic chemicals and the promise of green chemistry.
Tell us some other good news.
Well, one of the stories that I particularly like from the world of green chemistry is one that resulted in a non-toxic substitute for the formaldehyde-based glues that have been used in plywood and pressboard materials. A company called Columbia Forest Products has worked with a scientist who's actually based here in Oregon, who developed this non-toxic kind of glue after he had spent some time looking at how mussels and other shellfish cling to rocks when he was out at the beach. And he realized that these shellfish were holding on really, really tightly, and there was some material that was attaching them to the rocks, and it obviously wasn't a formaldehyde-based glue. Mm-hmm. So he took some of this stuff back to the lab, and he was able to recreate it synthetically and develop a commercially viable process. And this material actually won an EPA Green Chemistry Award a couple years ago, and it's now become an extremely successful commercial product for Columbia Forest Products, who were able to get into the market with non-toxic, non-formaldehyde plywood products that would, among other things, meet new air quality standards in the state of California.
That's fantastic. So this is plywood used in building and in furniture making as well?
Yeah, I think so. Yeah, I mean, and people have gotten sort of familiar with the hazards of formaldehyde, in part listening to those terrible stories coming out of Louisiana in the wake of Hurricane Katrina, where there were all those trailers that were brought in that had sort of pressboard plywood products that turned out to be off-gassing formaldehyde that was making people sick.
Making people sick, right. What's happening in cosmetics?
Well, cosmetics, lots of reformulations have been done on the one hand to get some of the known hazardous chemicals out of them. And similarly, there's been a lot of work to try and come up with non-toxic alternatives to so many of the chemicals that have made essentially different kinds of films and stretchy surfaces that go into things like nail polish or, I mean, it sounds so trivial, but, you know, a lot of the stuff gets sold, eyeshadow and mascara, because there are chemicals that are known as polymers, and all that means is that it's a long chain of molecules. But these things make all sorts of surfaces and films, and they're really useful in the semiconductor industry to etch microchips. That's a whole photographic film kind of process that's done. But it turns out the same kind of materials that make these really delicate, precise surfaces that you can use in electronics, you can use a very similar, if not same sort of chemical in cosmetics, because you're trying to do something like coat a pinky fingernail or an eyelash. So you want these very delicate, thin films, and there's some scientists who are at work trying to develop non-toxic alternatives that could be used in both industries.
That's fantastic. I mean, you say it's trivial, but, you know, so many women wear makeup, and then girls, younger and younger, they're getting, you know, my 12-year-old daughter now, you know, wants to wear makeup, and so you just add all those chemicals up over the years, and it's like a ticking time bomb, I think.
Exactly.
So
it's not, I mean, it's not trivial, but, you know, when you think of, you know, setting people off on this great journey of innovation, you think of, well, they must be trying to cure cancer or invent the next great telecommunication device. Well, no, we're actually trying to make a safe nail polish so the 13-year-olds who want a different color on each toenail are not going to be putting themselves in jeopardy.
Right. That's great. So what actions can consumers take? You know, what are 5 things that we can do right now?
Wow. Well, one of the things that I did while I was working on this book and writing articles that kind of went into it was I found myself asking the scientists who were researching the health problems particularly, what do they do? Based on what they've discovered, what do they do at home, and what do they tell their patients? Because a lot of them also have medical practices. And one thing I heard quite firmly was when it comes to plastics, particularly polycarbonate plastics, which are those hard, shiny plastics that make up the refillable water bottles. They've gone into baby bottles. There's a lot of sort of cookware and kitchenware that's made out of it because, it's not breakable and it looks good and it kind of holds up for a long time. Don't put that stuff in the microwave. Don't heat it up. Don't put it in an oven. And if you can find an alternative, do use it. In fact, the FDA just about a week or so ago just posted a bunch of recommendations on its website suggesting that people do use alternatives, particularly for baby bottles and when feeding infants and young children.
Right. Well, Lizzie, we're out of time, but this has been really fascinating, and I wanted to thank you and congratulations on your book, Chasing Molecules. And if people want to get a hold of it, what's the best way?
I would say, why don't you go to the book website, which is chasingmolecules.org, and there are links there to lots of other information, including more kind of things that you can do at home.